Hello students, in this video we are going to discuss 5.4 from work, energy and power. The potential energy function for a particle executing linear simple harmonic motion is given by V of x is equal to kx square by 2, where k is the force constant of the oscillator. For k is equal to 0.5 Newton per meter, the graph of V of x versus x is shown in the figure. Show that the particle of total energy 1 joule moving under this potential must turn back when it reaches x is equal to plus or minus 2 meter. Here the particle is in simple harmonic motion. When a particle is in simple harmonic motion, the total energy of the harmonic oscillator E is equal to sum of kinetic energy and potential energy. Here, kinetic energy is nothing but half mv square, which depends upon the velocity of harmonic oscillator, and potential energy is half kx square, where k is nothing but constant here, force constant, and x is the displacement from mean position. Here, the condition given is turn back where the particle will turn back at extreme position. So, at extreme position, he mentioned turn back, that represents at extreme position. At extreme position, V is equal to 0. That is, velocity of the particle is 0. Hence, kinetic energy is equal to half mv square is equal to 0. Therefore, the total energy will be available only in the form of potential energy, that is half kx square. From this, 1 joule is equal to half, k value is given as 0.5 into x square. This one will be x square is equal to 4. From this, x is equal to plus or minus 2 meter. This is the answer. That means this value can be plus 2 and this value can be minus 2. We can say these points are nothing but extreme position. It can be extreme, right? Coming to 5.5. Answer the following. The casing of rocket in flight burns up due to friction. At whose expense is the heat energy required for burning obtained? The rocket or atmosphere? Here, the answer is for A, the rocket. It is obtained at the expense of the mass of the rocket and its kinetic energy and potential energy. Coming to B. Comets move around the sun in highly elliptical orbits. The gravitational force on the comet due to the sun is not normal to the comet's velocity. Yet the work done by the gravitational force over every complete orbit of the comet is 0. Why? The comet is revolving around the sun in elliptical orbit. In this case, work done by conservative force is 0. Here, the gravitational force is conservative. We have studied work done by conservative force for a complete loop is 0. And the work done by conservative force is equal to minus of change in potential energy. But the change in potential energy, so this work done by conservative force, I am writing here. Conservative force. Relation is and here for one complete orbit over a complete orbit of any shape, delta V is equal to 0. Here V represents potential energy. Hence, work done by conservative force, that is nothing but here gravitational force is equal to 0. Coming to C. An artificial satellite orbiting the Earth in very thin atmosphere loses gradually due to dissipation against atmospheric resistance, however small. Why then does its speed increases progressively as it comes closer and closer to the Earth? Whenever it is coming closer, see, this is suppose say Earth. The satellite is coming closer. Whenever it is coming closer, the total energy for conservative force, for conservative force or forces, total energy is equal to sum of kinetic energy and potential energy. As satellite is coming closer, V value decreases. That means K value increases. That represents velocity increases. But here some dissipative force is there. That is nothing but resistive force, friction is there. But the total energy of this satellite goes on decreasing due to the loss of energy against friction. So even though some loss of energy goes on decreasing because of friction, potential energy decreases, then automatically kinetic energy has to be increased, velocity has to be increased. Coming to B. In figure 5.13, the man walks 2 meters carrying mass of 15 kg on his hands. In figure 5.132, he walks the same distance pulling the rope behind him. The rope goes over a pulley and mass of 15 kg hangs at its other end. In which case is the work done greater? If you observe carefully, in the first case, the displacement is towards left, but the gravitational force, that is but weight of the body, is downwards. The angle between them is 90 degrees. So work done here by the gravitational force is 0. But in this case, this block is moving up. How much displacement it is? 2 meters displacement. Gravitational force is acting downwards. That means here work is done but against the gravitational force. Work is done but against the gravitational force. So definitely in which case the work done is greater means answer is the second case. Will come further explanation. D. In case 1, no work is done against gravity because the displacement horizontal and weight is acting vertically downwards. Here only work is done only against friction. Case 2. Here work has to be done against gravity. So magnitude wise its value is nothing but mgh, that is 15 kilogram. G value if you are taking 9.8 and it is displacement to 294 joule. In addition to this one, place work done against friction. So therefore our answer is work done in case 2 in the second diagram is greater than that in case 1. This is the answer for D. Thank you.